In this section, we're going to talk about solving absolute value equations. First, let's talk about solving graphically. Solve absolute value of x equals 6. Well, I used Desmos and I graphed absolute value of x, looks like that, and I graphed 6, looks like that. And you can see they're equal in two places. They cross right there, and they cross right there. So our answers are, this one has x equals negative 6, and this one would be x equals positive 6. And if you take those and plug them in, it makes perfectly good sense, because if I plug in negative 6, I'd have absolute value of negative 6, which is 6. And if I plug in 6, absolute value of 6 would also be 6. All right, second problem. Now this one's slightly more complicated. We have absolute value of x minus 2 equals 3. The graph of absolute value of x minus 2 is this green one, and 3 is the horizontal line. Once again, we can see they cross in two places. So one of the answers is here, x equals negative 1, and the other answer is here, x equals 5. And again, if I take these numbers and plug them in, it makes sense, because negative 1 minus 2 gives me negative 3, and the absolute value of negative 3 is 3. And if I plug in 5, 5 minus 2 gives me 3, absolute value of 3 equals 3. So look what's really happening here, these two answers. The two answers come from whatever's inside could be the number negative 3. Because when I take the absolute value of negative 3, I'm going to get the answer 3. The other possibility is whatever is on the inside turns out to be positive 3, because the absolute value of positive 3 is also 3. All right, so that leads us to how we solve these algebraically. So number one, we just pretty much did. What we recognize is when I take an absolute value, if I'm going to get an answer of 3, there's two ways that could happen. One way that could happen is whatever's inside the parentheses could be negative 3, because absolute value of negative 3 would give me 3. Or the other possibility is whatever's inside the brackets could be 3. So notice what was inside the bracket doesn't change at all. It's still x minus 2, it's still x minus 2. What changes is this number out here. This number could be 3, or this number could be negative 3, because absolute value of negative 3 gives me 3, and absolute value of 3 gives me 3. And then we simply solve each one. We add 2 to both sides, x equals negative 1. Over here we add 2, x equals 5. All right, so let's try this next one. We have absolute value of 2x minus 5 equals 4. Well, what happens is the thing inside the bracket could be negative 4, because absolute value of negative 4 would be 4. So 2x minus 5 could be negative 4. Or the other possibility is what's inside the brackets could be positive 4, because the absolute value of positive 4 would also give me 4. So that's pretty much how we solve these absolute value equations. Once we have the absolute value equals a number, we set it equal to the exact number it is, and we set it equal to the opposite number. Solving each one, 2x equals negative 1, x equals negative 1/2. Over here, 2x is 9, x is 9/2. All right, well, there is a little bit more to it. And a little bit more is if you have a problem like this, where we have an absolute value, but we have numbers outside of the absolute value. What you need to do first in a problem like this is you need to get the absolute value thing alone. So what I'm saying is, start by adding 2 to both sides. 4 times absolute value 3x plus 5 equals 8. And then you go ahead and you divide both sides by 4. Absolute value of 3x plus 5 equals 2. So there's your first couple steps. If you have numbers on the outside, you need to get rid of those numbers. You need to get the absolute value thing all by itself first. Once you have the absolute value all by itself, then you write the two equations. We could have 3x plus 5 equals negative 2, or 3x plus 5 equals 2. And we just go ahead and we solve both of those. So we subtract 5 3x equals negative 7. So x is negative 7/3. And same thing here, we subtract 5, 3x is negative 3. And when we divide, we get x equals negative 1. So you'll notice for these absolute value equations, we seem to get two answers. Well, you don't always get two answers. There's a couple little trick questions here. How about absolute value of x plus 5 equals 5? I'm sorry, absolute value of x plus 5 equals 0. Well, there's only one way that you can take absolute value and get an answer of 0, and that would have to be x plus 5 equals 0. That's the only way that can happen, because the absolute value of 0 is 0. The absolute value of any other number does not give you 0. So this is the rare example on an absolute value equation where you only get one answer. And then finally you have these, which are even a little bit trickier. These are a little bit nasty questions. But think of what happens here. On the left-hand side, I take an absolute value. When I take an absolute value, I never get a negative answer. If I take absolute value, I might get 0, or I might get positive answers, but I never get a negative 6. So this is kind of a trick question. This one has no solution. There's no answer to that equation. All right, just a quick reminder of how you might solve these equations in Desmos. Let's do number 3. You would type y equals 4, and then you use the absolute value sign, 3x plus 5 minus 2. And then you go down to the next line, y equals 6. And then you just go to where they cross, negative 2.333 and negative 1. Now, what I don't love about Desmos is I would really prefer the fraction answer. Decimals rounded off are not as good, so the fraction answer would be better. And then let's take a look at the last one just to show you what's happening there. Y equals absolute value of 2x plus 4, and y equals negative 6. And you can see what's happening. Those two graphs never cross. And that, again, makes perfectly good sense, because when you do an absolute value, you always get positive numbers or 0. No way you're going to get a negative value.